Hi everyone, I hope you are doing good. So let's have a new DSA question today, coin change problem. So here, let's understand the problem first, and then we will discuss the solution algorithm, and then we will implement that algorithm, whatever we will discuss, into the C++ code. So let's start without wasting time. So the problem is given an integer array. So you will be given one integer array, coins, right, representing different denominations of currency and an integer sum, right. So one array will be given and one sum will be given, right, and that array will basically having the denominations, all the denominations whatever we want to support, right. Find the number of ways you can make sum by using different combinations of the coins, right, and not assume that you have an infinite supply of each type of coin, right. Whatever the denomination is given in the array, so the supply would be infinite, right. You can take as many coins as you want of particular denomination. So let's understand with the example here. So the coins we have given one array here, 1 2 3, right. So 1 2 3, these are the denominations of the coins, right. 1 rupees coin, 2 rupees coin, 3 rupees coin, right, and the quantity is infinite, right. That is what it is mentioned here. You can use any coins as many times as you want, right, and sum is 4. So how can we make 4 using these denominations, right? How many ways there are that we have to find basically. So sum is 4. So there are 4 ways. How 4 ways here? Let's understand this one. So if we use 1 rupees coin 4 times, right, then we can make 4, correct. The another way is we can use 1 rupees 2 times, right, 2 coin of 1 rupees plus 1 coin of 2 rupees, that will also make 4, correct. And the third way is we can use 2 coins of 2 rupees, that will also make 4, correct. And the another way is we can use 1 rupees 1 coin and 3 rupees 1 coin, right, that also will make 4 rupees, right, 4 sum, correct. So these are the ways to make the sum, that is 4, using the given denominations, correct. So I hope you understood the problem. It is not that much rocket science, right. So let's move to the solution. Think about the solutions. How can we solve this problem using any generic algorithm, right, and start with the brute force, and then we can optimize that solution. What I am thinking is the one way is we can solve this problem by using the kind of dividing, right. For example, we have this array, right, 1 comma 2 comma 3, this is the array and we have to make 4 sum, right. So what we can do, we can include one element, right, and the another is we can exclude, right, include and exclude, what we can do, right. So for example, this we are having 4 sum here. If we include this element 3 here, right, in that case the sum would be sum would become 1, correct. Sum would become 1 here if we include 3, right. It means we have to subtract that denomination from the current sum, correct. So 1, and if we exclude this one, then sum would be 4, right, because we are not basically including any coin here. But if we, for example, if we are excluding from the end, so then our array would be 1 comma 2 here, correct, here. Then again after this we have included this one 3. Then if we include again 3, right, if we include 3 again, then it would be minus 2, right, minus 2 we are getting. And if we exclude, in that case we will see 1 comma 2 array, and or 1 would be as it is, correct. I hope you are getting it. What we are doing this side, it means we are including this, and here right side we are excluding, right, we are excluding here, correct. So and here we have included minus 3, right, because 3 is our denomination here, correct. So 1 minus 3, that is minus 2 here we are getting, and that is going beyond the sum, right. Sum must be greater than equals to 0, and number of coins, right, number of coins in the array, those also should be greater than 0, correct. So here, and here number of coins would be 2, right, here also 2 if we exclude the 3, and here again we can go and include this 2, right, this one. So if we include the coin 2 then it would be minus 2. So 1 minus 2, that is 1 minus 2, that is minus 1, right? This is also minus 1, right? So that we cannot do, correct? And then what we can do, so we can exclude this coin also, right? And then our array will have only one coin, right? And here the sum of the value would be 1 only, because we are not including any coin here, correct? I hope you are getting it, right? And if we include this coin now, then minus 1, so it would become 0, right? And that is the correct, right? Now we found the way, right? One is this one, we are including minus 3. Here we are including this minus 3, and we are including minus 1, and we are making some 0, right? So this could be one combination. 1 comma 3 is one combination here, right? What we found here. And if we exclude this one here, if we exclude by coming from here, if we exclude here, then our size basically our array becomes 0 size, right? Empty, right? So we will return from here also. So we found one combination here, correct? Now if you talk about here, the first position we excluded the 3, right? And we are with 1 comma 2 only, and we have the sum is 4. So what can I do here? Let me take it this side. So 4, right? And we have now 1 comma 2 only. Now if we include 2, right? If we include 2 in that case, or sum will become 2, correct? That is correct, greater than 0, right? It is possible. And if we exclude, then our array will have only 1, right? And our sum would be as it is 4 only, correct? And here if we again and here array is 1 comma 2, correct? Here 1 comma 2 only, right? So if you include again 2, then it becomes 0, correct? And that is what we are looking for, right? Making sum to 0. So here there are this is the another combination we found, 2 and 2, right? So another combination is 2 comma 2, right? Which is also making sum to the 4, right? Correct. And now from here the another combination we will get from here. If we exclude this 2, then our array will have only 1, right? And our sum would be 2 only, right? Without any change, correct? And now we include this element, this one element we are having here, and if we include this one, then we will subtract from this current sum, right? Minus 1, so it will get 1. And then again if we include this one, then again minus 1, and then we will get 0, right? So here you see we found another combination here, right? Because we are getting 0 here, right? 1 1 and this 2, correct? This one we will not, this is the different path, right? So this is 2, then again 1 we included, and then again we included 1, right? So the another combination we found is 2 comma 1 comma 1, right? So these are the combinations, right? And here if we go right side, right, here if we exclude, because here the current array is 1 only, right? If we exclude, then we will get sum is 1, and we get empty array, right? So we will come back here, and same here, right? We have, because we have only one element, if we exclude that element, then the coin array would become 0, right? Empty, correct? So now coming back to here on 4, if we exclude here, right, then our array becomes empty, right? So we will not exclude. Now we will include this one 1. If we include this one, then our sum will become 3, right? Again we include this one, right? Then sum would become 2, and again we include 1, then sum would become 1, and again if we include 1, then our sum would become 0, right? So what does it mean by getting sum 0 is like we found the combinations, right? So what we included, 1, then again 1, then again 1, and then again 1, right? So you can see here 4 times 1 we included. So this is the another combination, 1 comma 1 comma 1 comma 1, right? Which is also making sum to 4, right? Here we are going in reverse direction, 4 to 0, correct? And if we exclude anywhere, because we have only one element, then it will become the empty array of coins, correct? So this is the one way of solving this problem. So let's add a recursive function for this one, for this logic, whatever we have discussed. Our function is integer count, right? It will take array, then n, right? The size of the array, and then we can say sum, right? For this we are looking, right? Sum, correct. And then what we can do here, base condition. So base condition would be if n is less than equals to 0, yeah, or sum is less than 0, right? In that case what we will do, we will return 0, right? And another condition we can add, if sum is 0, it means we found the combination, right? In that case what we will do, we will return 1. It means we found one combination, so we are returning count only, right? That is why we are returning 1 here, correct. And then after this what we can do, else we can return, we can call it again recursively. So one is count, right, or count a n and sum, it would be, so let's exclude this one. So this condition we let's add for exclude. So n minus 1 and sum plus count a n and sum minus a of n minus 1, right? So the first condition I have the first call I have added this one, this is for exclude, right? Exclude. And the second call I have added for include, right? So see here, you will see we are left side, what we are doing, we are basically including. When we are including, in that case what we are doing, the last element whatever we have in the array, we are subtracting that element from this sum, correct. That is what I am doing here, including sum minus a of n minus 1, right? A of n minus 1, it means last element whatever we have in the array, we are subtracting that element from the sum, right? And then that sum we are passing to the next call, right? And in exclusion what we are doing, n minus 1, right? We are basically reducing the size of the array, or you can say in another way, you can say we are excluding that element from the array itself, right, for the next call, and we are passing some as it is whatever we have. That is what we are doing here also, correct. So I hope you understood this problem. I will also show you the C++ code for this one also, so don't worry. So let's talk about the, and the time complexities would be 2 to the power sum, that is exponential, right? So let's think about another solution which can be optimal solution, right? So let's talk about that. So let me clear this first. So let's discuss the second approach because it is taking exponential time complexity, right? So let me, and the second approach would be using the DP, right? We will use the dynamic programming, and using that we will solve this problem from 2 to the power sum, right, to the order of n square, right? From exponential to, we will solve it into the order of n square. So let me add the algorithm first. So what I will do, first step, I will basically create one dp of n plus 1 and then sum plus 1, right? And then second step what I will do, I will initialize this complete dp, I will initialize with 0, right? That is and then dp of 0 comma 0, right? 0 comma 0 I will say 1, right? And then third step what I will do, I will basically check for this for loop. So for loop I should be 1, I should be less than equals to n, and here I plus plus, right? So here you have to notice I less than equals to n because I am taking n plus 1 size, right? That is why. And then one more loop I will take here, for loop, it would be sum s equals to 0, right? S less than equals to sum and s plus plus, right? And here what I will do, first whatever we have computed, let's copy that from the previous sum, right? So for that dp of I comma j is equals to dp of I minus 1 j, right? And then what I will do after this, I will check for the including. So this part is for exclude, right? This part is for exclude, right? Exclude, right? It means we are not including the current coin, correct? And the second part I will add for the include part, right? So include I will check if uh, uh, s minus whatever coin we have, right? So here coins of I minus 1 is greater than equals to 0 if this condition is fulfilling. So what does it mean? It means like we have already computed for the positive numbers, and if it is giving negative number, in that case we can say it is not basically includable. We cannot include this one, right? So if it is true, in that case what we will do, we will update dp here. So dp of I comma j, so plus is equals to dp of I and s minus dp of, sorry, coin of here, coins of I minus 1, this one, right? And here we will close the loop, right? And at the end what we will do, we will return dp of n and sum. This is the value we will return, right? So don't worry, I will explain it again. So let's do a dry run here for this use case, right? So what I will do, I will create here dp, right? What I will do, I will create here dp of n, here n is equals to 3, right? And sum is equals to 4, right? So 3 by 4 we have to create, right? So we will take 1 plus n plus 1 and sum plus 1 matrix, right? N plus 1, sum plus 1. So let me have a row here, 4 rows and 5 columns. So 1, and this is 5 columns we have, right? 0 1 2 3 4, 0 1 2 3, correct? And here 0 0 we have already I have told you, right? 1, this one. So I will make it 1 here. Now see here, I is equals to 1, right? I will start from 1, and here sum will start from 0, correct? So what I will do, so this is the DP, dynamic programming, and what does it mean by dynamic programming? It means we calculate and we reuse the already calculated results. That is what we are going to do here, right? In recursive programming, what we were doing, we were basically every time we were calculating, right? Repetitively we were calculating, right? That is why it is going in the exponential time complexity, right? And here we will do it in order of n square only, right? Because we have here 2 loops, 1 loop and 2 loop, right? So this is 1, and it will have 0 0 0, correct? Because all this matrix, all this 2D array I have initialized with 0, right? Correct? So now here I is 1, correct? And then s is 0. Then I will update this one, 1 comma 0, correct? 1 comma 0 is this one, this block, and this will be updated with the I minus 1, right? I minus 1, that is I is 1, 1 minus 1, that is 0. So 0 comma 0, this previous value I will update, all right? So now onwards I will directly say whatever the value we have for the that particular sum, without this current basically these are the coins, right? Coins, and these are the sum, correct? So without this, without including this one, whatever value I have, that is 1, right? So I will directly copy it here, correct? And then I will check for the including. So this part I have added, this part is for include, right? Include, right? Correct. So this part is for include. So let's check for the inclusion of this coin, right? Can we include or not, right? Sum is 0, s is 0, 0 minus coin of I minus 1. So what is the current coin? That is 1, right? So here 1, and it is not greater than equals to 0, correct? It is not, so we cannot include this one, right? So let's move for the next sum. So next sum is 1, right? For 1, let's try for 1. 1, copy the earlier data, that is 0, right? We just copied it from the upper row, right? It means without including this coin, can we make 1? No, right? Already we have 0, we have already computed it 1, correct? So let's try that one. So sum is 1, 1 minus current coin is 1, right? 1, yes, it is 0, yes, it is greater than equals to 0. It means what we have to do now we got this is 0 value, right? So for 0 value, whatever the computed value is, so we have to look into the DP. So that is 1 here. For 0 we have 1, right? So we will add that value to the current value. Current value is 0, which we got from the previous result, right? 0. So 0 plus 1. So now we will add it to 1. So it would be 1, right? So what I will do, I will update this one here, right? And it would become 1, correct? And likewise the for second also, for second sum, right? Sum is 2, current is 1, that is we are getting 1, right? And for 1 we have value 1, right? And here from upper we will get 0, 0 plus 1, that would be 1. So here also it will be 1, right? So likewise 3 and 4 also we will get 1 1 1, correct? Right? So this is the first coin only. We have included only 1, right? In coins we have included 1. Now let's include second coin also. right? 2. So without including what would be the value for 0 sum, right? So let us start 0 again, from here also 0, right? And this is 2, I is 2. So now without including this one, only 1, correct? Now include this one. So for this inclusion we have to check this condition, sum should be greater than equals to 0. So sum is 0 minus current coin is 2, right? Current coin is 2 here. So 2, and it is not greater than equals to 0, so we cannot include this one, correct? So now go for the second sum here, then 1. For 1 also we cannot do it, because 1 minus 2, that is also becoming negative. So here also only one way. For sum 2, what we have to do? So 2 minus current value. So let's copy from the upper value, whatever the value is there for the without including this coin, right? When I say without including, it means without including the current coin. Current coin is 2. So without including this one, can we make 2? Yes. And how many ways there are? 1 only, right? So that I am copying here for this one, without inclusion of this one. Now after inclusion of this one, so sum is 2 minus the current coin is also 2. So it is giving 0, right? It means then it is becoming 0, right? And for 0 we have value, yes. So what is the value? One way. One way is there to make 0, right? With this coin, right? 2. So that value would be added here for this 2. So it would be 1 plus 1, that is 2 here, right? Now you got, right? We got here 2. How it is 2? And like, let's confirm this one. So we have 1 and 2 coins, right? And or sum is 2. So there are 2 ways, 1 comma 1, that is one way, and including this 2 also separate, that is also one way. So this is how we are getting 2 here, right? To confirm, I am just telling you for confirmation only, right? So let's talk about the sum 3. Now let's talk about sum 3, right? So sum is 3. Now sum is 3, and here we have 2 coins, 1 and 2, right? So let's, without including this this coin, this 2 coin, how many ways are there? One way, right? Just copy it directly, and then just check for this one inclusion, just include even. So sum is 3 minus whatever the coin we are including, that would be 2, right? And here we are getting 1, right? And for 1 we have, and it is greater than equals to 0, correct? And the value is 1. For 1, how many ways are there? With this 2 coin, with this coin, right? 2 denomination coin. So 1 way is there. So 1 plus 1, that it would also become 2, right? And now go for sum 4, right? So for sum 4, we have, without including this coin, this second coin, right? We have 1 way. So let's copy this 1 way directly. And then with inclusion, so what will be the inclusion? 4, that is sum, minus current coin value, that is current coin denomination, that is 2, right? It is 2, right? So for 2 we have already value. There are 2 ways to make 2 with this coin, right? Plus 1 way we have already. So 1 plus 2, that is 3, right? So here we got 3 ways, right? Now let's include one more coin here, 3 coin, right? So third coin also we have included. So now the coin array would be 1, 2 and 3, right? 1, 2, 3 are the denominations, right? Don't be confused with the 1, 2, 3. It could be 2, 5, 3, whatever, right? Denomination we can give. And then here also, let me start with sum 0, right? Now sum is 0, and we have 3 coins, right? So what is the previous value? Previous value means without including this third coin, what is the value? That is 1. So let's copy it directly, right? And then try for the inclusion of this this coin, third denomination coin, right? 3 denomination coin. So 0 minus 3, it is becoming negative number, right? Minus 3. So we will not include this one. It cannot be included, right? Then let's go try for the sum is equals to 1, right? So copy it without including this one, that is 1. And this is also 1 minus 3, that is also negative number. We cannot include this one. Then go for the sum 2. Sum 2 also we will copy the previous value. It is 2 without including this current coin, here 2. And 2 minus 3, this is also negative number, so we cannot include the coin here, right? We cannot make the sum, right? And then let's go for 3. Sum is equals to 3, 2, 3, right? So 3 minus 3, it is 0, right? It is 0. And for 0 we have already calculated, and 3, the previous value is 2. So we have already calculated 1. So 1 plus 2, that is 3, right? So it would become 3 here. And for 4, sum is equals to 4. So for sum is equals to 4, also we have the previous value without including this one, 3, right? So this is 3. Now with inclusion of this the third coin, which denomination, the denomination is 3 for this coin, third coin. So 4 minus 3, right? It is also greater than equals to 0, so we can include, and the value is 1. So for 1 we have already value, right, which we have already calculated, that is 1. So 1 plus 3, it would become 4. So now it would become 4, right? And now we are out of the array, we are done, right, with our answer. So our answer in this case, it would be the last element, this is 4, right? So that is what I have added here, right? Return dp of n comma sum, right? This is the value 4, correct? So I hope you understood this algorithm. Let me show you the C++ code for this algorithm. So where also I did the same things, right? So this is the first approach. We tried the recursive one, right? Here we have base conditions too. If either empty array or the sum is less than 0, in that case we will return 0. And if sum is equals to 0, it means we found the combination, right, of the coins. So then we will return 1, right? And here we are, what we are doing here, this is the for the inclusion part, and this is for the exclusion. It means one time we are including the coin. In that case, if we are including the coin in the array, right, then we are keeping the same n here, the size of the array is same, but we are basically subtracting that current coin value denomination from the sum. That is what we are doing, and this new calculated sum would be the sum for the next call, right? And here for the basically exclusion part, what we are doing, we are keeping some same as it is, right? But we are basically removing the last element because we are excluding that last coin. So for example, we are excluding this coin, right, third number coin, right, that is denomination is having 3, right? So in that case, the next call will have only 1 comma 2. This is the array for next call, right? And sum would be same, correct? I hope you get it. And yeah, so this is the, and here it is taking 2 to the power sum, right? Exponential time complexity it was taking. That is why we thought of optimizing this solution, right? And we came up with the new solution, right, here, which is which in which we have used the dynamic programming, right? And here we have solved this problem into order of n cross sum, right, using the dynamic programming with extra space, right? So there also we are taking the extra space for call stack, right, for storing the call stack. So let's have a look into it. So here we have, I have added this condition. This is like if either we have empty array or sum is less than already equals to 0. In that case, we will return 0. Else, what I will do, I will create. I have created one vector of vector, that is 2D array, basically n plus 1, and here sum plus 1, right? And I have initialized this 2D array with 0, right? So you have to notice it. And then what I will do, I am basically initializing the first element, right? I0, J0, it means row 0 and column 0, this one with 1. Why I am doing this one 1? Because we have the sum is 0. It means, and we have empty array, right? Sum is 0 and that array is empty. In that case, there is only one way of making the sum 0, right? Because we cannot exclude this one, we cannot include, right? So that is why I have initialized this one with 1, correct? Here now coming down, we have, I have added this one for loop here, right? What I am doing here, I am starting from 1, I equals to 1 to n, right? And then j equals to, it would be I have taken s for that algorithm, right? So here it is j. So j equals to 0 to j is less than equals to sum, right? So this is for sum and this is for the coins, right? This is for coins and this is for sum, correct? And here I am basically excluding, right, without, or you can, in other words, you can say take wage without including current coin. Either you can say exclude or you can say without taking, right, without including, right? Those are the same things, right? So without including the new coin, I am taking the result whatever we have already, right? So that is what I am copying in the current block of dynamic of this DP array, right, 2D array. And here I am checking for the inclusion part. Here I am checking the condition if j minus coins of I minus 1 should be greater than equals to 0. In that case only we will include this one, else we will leave it, right? That is what I am doing here. And with current value I am adding, right? I am adding the new value with the current value. See here I am plus equals to, right? So it would be dp of I comma j equals to dp of I comma j plus, and then this one, right? So this part will come here, correct? So that is, I hope you know it, right? So that is what I am doing here, adding the current value, right, with the previous value. and after this I am returning this dp of n comma sum, correct? This would be the last value, and this would be your result, right? So I hope you got it. Let's run it quickly, and then we will conclude the session, right? Here you can see your output is 4, right? And that is what we have expected here, correct? And 4 are like this 1 comma 1 comma 1, that is one combination here. 1 comma 1 comma 2, this is another combination here. Then 2 comma 2, this is another combination. 1 comma 3, that is another combination. So these are the 4 combinations we got it here, right? So yeah, that's all for today. Yeah, see you next time. Till then, keep learning and keep exploring.